Dominica State College Math 1-1 Final Assessment, Section B, Practice Questions. Number 5. Shanna selected one fruit at random from a box containing 27 berries, B, and 14 cherries, C. She ate it, then randomly selected another. Construct a well-labeled tree diagram to analyze all the possible outcomes with their corresponding probabilities. So this is a scenario of selection without replacement. So 2 selections will be taking place, one after the other, and all the possibilities can be displayed using a tree diagram. So we are going to weekly notes number 10, unit 10 in the Google Classroom to obtain assistance to solve such a question. So we are going to the Google Classroom CI3QYBO, and I'm going to classwork, and we're going to weekly notes. This comes in the Word, PDF, PowerPoint, and video format. We are going to open the PDF format. Here it is, probabilities in week 10, unit 10. So let's go into this unit to obtain information with regards to the tree diagram to analyze an experiment where you've got selection, 2 selections, one after the other without replacement. So here we have a template of the tree diagram that is used to display all the possible outcomes for an experiment where you have 2 trials or 2 events happening one after the other. You've got a first section and a second section, and you've got nodes, and the probability across any node must add up to exactly 1, and not only 1, and only 1. And the outcomes are calculated using the intersection, the formula for intersection using the probabilities in conditional events happening one after the other. And the second section makes use of the if symbol. Okay, so let's look at an example that depicts such a scenario. So example 10.9 analyzes a situation where you've got selection without replacement. As you can see, the denominator has decreased by 1 because whatever has been selected was not replaced. And to calculate the outcomes, you've got multiplication going on along the branches. So we are going to use another document to help us demonstrate how this problem can be solved. So in this very same Google Classroom CI3QYBO, we go to classwork, and then we go to Math 1-1 course information, Math 1-1 interesting readings part 1, and we've got the without replacement document. Okay, so we're going to download this file, and we are going to, as you can see, we have with replacement and without replacement to use it to help us analyze such a situation. So we have downloaded the file, and here we have a situation with grapes and cherries. What we have to make it, modify it to suit our scenario. We are dealing with berries and cherries. 27 berries and 14 cherries to be exact, as the first condition of the box. So you've got 27 berries and 14 cherries in the initial stages of the box. A first selection is done, one fruit is randomly selected, then eaten. A second selection is repeated, and another fruit is randomly selected, then eaten. Well, you're only using only 2, so a third fruit is not selected. The diagram displays all possibilities. So in the first selection, the total number of fruits are 27 berries and 14 cherries. So in the first selection, there are 41 fruits in all. So it is possible for her to select a berry or a cherry. And these two possibilities are represented by branches, a berry or a cherry. Now, the probability of selecting a berry is 27 out of 41 in the first selection by virtue of this fundamental formula for probabilities. Analytically, if there is a total number of trials or successes or availability of that element, and you've got a number of successful trials, then the probability is the frequency of occurrence over the total frequency. So in the case of fruits now, simplified explanation, in the first selection, there are 27 berries out of the 41 fruits. So the probability of a berry in the first selection is 27 out of 41. And the probability of a cherry now in the first selection is equal to 14 out of 41. And just to verify, 27 plus 14 is 41 out of 41. The total probabilities across any node must add up to 1. So that is the possibilities in the first selection. Now, whatever fruit she has selected, be it a berry or a cherry, she's going to eat it. So there's going to be one fruit left. So then she's going to select another fruit. So in the second selection, it may be that the condition of the box will be 26 berries and 14 cherries. That will be a total of 40 fruits in all, or 27 berries and 13 cherries, 40 fruits in all, depending. So what if it was another berry she has selected? Given that, what if she selects a berry in the first? Then there will be 26 berries left when she go to select again. I repeat, what if it was a berry that she selected in the first selection? Then when it comes now to the second selection, there will only be 26 berries. So therefore, if a berry in the first, there are not 26 berries when she comes to select. So the probability of a berry, if it was a berry she has selected in the first, is 26 out of 40. But she could select a cherry if it was a berry she selected in the first. But if it's a berry she has selected in the first, there will still be 14 cherries left when she comes to select again. So we are going to analyze a cherry if berry in the first. So the probability of cherry if berry is equal to 13 out of 40, because there will still be 14 out of 40, because there will still be 14 cherries left if it was a berry. But what if it was a cherry she selected in the first? It is possible to select another cherry. And if it was a cherry, then there will be one cherry less. So let's analyze this probability. So a cherry if cherry, all right, a cherry in the second, if it was a cherry in the first, is 13 out of 40. But if she had selected a cherry, it is also possible that she could have selected a berry if it was a cherry. So let's analyze this probability. So therefore now, the probability of selecting a berry in the second, if it was a cherry, she selected in the first. Berry, if cherry, is 27 out of 40. Now to analyze the outcomes now, we've got to multiply along the branches, okay? So after both selections has taken place, what can happen? So it's possible for her to select a berry and a berry. Bear in mind, we are using the word and. So therefore, berry and berry. Berry in the first, then berry in the second. That's two berries. So the probability of berry and berry is 27 over 41 times 26 over 40. That will give us 0.428. Now, an outcome could be that berry in the first and cherry in the second. We're going to multiply 27 over 41 times 14 over 40 to get a berry and cherry. So berry and cherry, this means berry in the first, then cherry in the second, berry, then cherry. Okay, B, then C. B and C is 27 over 41 times 14 over 40, which will give us 0.230. Now, it's also possible that she could select a cherry, or one possible outcome could be selecting two cherries, a cherry in the first and a cherry in the second. Let's analyze what's the probability of this happening. So therefore, the outcome of cherry, then cherry, cherry in the first, then a cherry in the second, that's two cherries. That's 14 over 41 times 13 over 40, that's 0.108. But it's also possible to select a cherry in the first, then a berry in the second, all right? Cherry, then berry. So let's analyze how probable is that. So the probability of selecting a cherry in the first, then a berry in the second, that will be 14 over 41 times 27 over 40, that will be 0.230. So now we have displayed all the possible outcomes from this experiment together with their probability values. Now we're going to answer some follow-up questions, and we are not required to go back into the tree. We must use the outcome values. So we have completed the tree diagram. We're going to answer, what is the probability that she select two cherries, a cherry followed by a cherry? And here it is. A cherry, then a cherry is 0.108. There's like a 10% or 11% approximately chance of her selecting a cherry, then another cherry. Now, part two, what is the probability that she selects a berry followed by a cherry? We do not have to go back into the tree. We can come to the outcomes and get this probability value. A berry and a cherry. A berry and a cherry, 0.230. So berry, then cherry is 0.230. At least one berry. What is the probability of us selecting at least one berry? At least one berry makes provisions for two. So it could be one or two. Now there are two different ways of selecting one berry. A berry in the first, then a cherry in the second, or a cherry in the first, then a berry in the selection. And or implies that we add, or two berries. So we're going to add three probability values there. So notation-wise, berry, at least one berry, that would be berry in the first, then a berry in the second, or cherry in the first, then a berry in the second, or two berries. So that will be equal to berry in the first and cherry in the second is 0.230. Cherry in the first Then berry in the second is also 0.230. And two berries would be 0.428. And this would be equal to 0.888. Here's the completion of the use of the tree diagram to analyze an experiment where you've got two selections, one after the other, without replacement.